This lesson is on adding and subtracting rationals. Some of this will be very easy. You're welcome to fast forward through. On the first fraction, we of course need to get common denominators. The common denominator here would be a 21. In this first fraction, I would have to multiply the 3 times the 7 to get 21, so I must do that to the top. I'm going to record it down here. Plus, the second fraction would have to be multiplied by 3, so I have to multiply the top by 3. So there we go. Now we have common denominators and we're allowed to add our numerators. I'm going to distribute. Remember, at any point in the video, pause and do your own math and catch up. 7x plus 6x is 13x. The 35 minus the 3 is negative 32 over 21. This cannot be reduced at all, so this is your final answer. I'm going to move it up here. Whoops. Take the box with us. That goes here. Let's go on to number 2. Number 2, the common denominator is a little bit harder. Not much, though. The common denominator would be both an x minus 6 and an x plus 10. In the first fraction, since I had the x minus 6, I need an x minus 10 on top and bottom. So this is 8x minus 10. In the second fraction I had, I'm sorry, that's plus 10, isn't it? Put a plus there. X plus 10. On the second fraction, I had the 9, I had the x plus 10, I need the x minus 6. What we do to the bottom of a fraction, you must do to the top. Now, by the same fashion we did in number 1, we're going to distribute. So we have 8x plus 80 plus 9x minus 54 all over x minus 6, x plus 10. Combining like terms, the 8x and the 9x equals 17x. 80 minus 54 gives us positive 26 all over the denominator of x plus 10, x minus 6. 17x plus 26 over x plus 10, x minus 6. Number 3. Before you start number 3, you must factor each part. So I'm going to rewrite the question here. Let's get a new color. So we're going to have x plus 11, but we're going to factor this bottom into what multiplies to be 56 that adds to be negative 15, which will be x minus 7 and x minus 8 plus, let's put the 2 in the numerator. Let's factor what multiplies to be negative 77 that adds to be 4 would be x plus 11 and x minus 7. Now, as you can tell, this time in our common denominator would be common denominator is x minus 7. Whoops, hang on. X minus 7. And we only need one of them. Even though it's in both, we only need one. X minus 8 and x plus 11. Now, let's change colors. This first fraction already had the x plus minus 7 and the x minus 8. So I'm going to have to put into the second fraction, I need an x. That doesn't look very good. I'm going to have to, let me scooch this over, guys. Okay. So let's go with this again after I have more room for myself. So since we have the x minus 7, the x minus 8, this first fraction needs the x plus 11. So since I put it in the bottom, I have to put it in the top. Be careful, it's kind of tricky since there's already an x plus 11. But now you have two of them. Plus, now on the second fraction, I have my x plus 11 and I have my x minus 7. I'm missing the x minus 8. Since I put it in the bottom, I have to put it in the top. There we go. Now I'm ready to distribute and collect terms. On the left side, I'm going to need to FOIL. So this will give me x squared plus 22x plus 121. I FOILed that all in one step. Pause and box it out if you need to. Distribute the 2x minus 16 over, and you do not have to FOIL these back together. Now let's combine our like terms. X squared, there's no more x squared, so this is going to be x squared. We have a 22x and a 2x to make 24x. And then we have 121, take away 16, which will give us positive 105. Okay, so the let's undo that. The denominator on this one would be x minus 7, x minus 8, and x plus 11. Now, I guess we need to double check. We probably ought to, at this point, double check. Does anything multiply to be 105 that adds to be 24? Okay, 20 times, well, you know what? Even if it does, it's not going to cancel with anything below. One thing you have to double check on is that if the numerator would factor, and when it factored, if it would cancel with something below, you have to make sure you get that done. So this 105 would factor 21 times 5, so we could factor this to x. Nope, that still wouldn't factor. That's not going to work. So that doesn't factor. Sorry, thought we could factor that numerator. Looks like we can't. So this is not factorable, so therefore nothing will cancel, so you can leave that in those terms. So again, just to double check that you understand, if the numerator was factorable, and you factored it, and let's say there was an x minus 7 in the top, and then you could cancel it with this one in the bottom, you would have to make sure that you did do that to reduce the fraction to get it into lowest terms. Okay, let's go back and do the last example here. I'm going to erase. We're going to do example 4. Now, the good news on example 4 is you do not have to rationalize your denominator. You do not have to rationalize your denominator. You can have the square root in the denominator. So this isn't really that hard, even though it looks a little bit scary. It's not so bad. If we put a 1 under here, if I put a 1 under there, what's your common denominator? It would be the square root of 1 minus x squared, right? So let's think this through. That means to get the common denominator of 1 minus x squared, I would have to multiply this by 1 minus x squared. If I multiply the bottom by 1 minus x squared, I'm sorry, the square root of 1 minus x squared, I'm saying that wrong, but I wrote it right. If I multiply the bottom by the square root of 1 minus x squared, I have to multiply the top by the square root of 1 minus x squared. So the top would be 2x times the square root of 1 minus x squared, right? Because I have two of them now. Minus, nothing needs to happen on this second fraction here. It already has the common denominator, so I'll just put my x cubed right there. Now, what is the square root of x squared? Well, they're inverse operations, so it will just undo itself. So the square root of x squared is just itself 1 minus x squared. Distribute, and we get 2x minus 2x cubed minus x cubed over the square root of 1 minus x squared. So combining like terms, we get 2x minus 3x cubed over the square root of 1 minus x squared. Now, you're allowed to leave it this way because on a calculus AP exam, they don't make you rationalize your denominator. Okay? They do not make you rationalize your denominator. So this would be a perfectly good answer. If you decided, well, I'm going to show them that I can rationalize my denominator and made a mistake along the way, you would get it wrong when you would have been okay if you'd have just left it unrationalized. But let's pretend it's a multiple choice test and it is rationalized. What would this look like if it were rationalized? I will take either answer. But this, if we decided to rationalize it, I would take the equation as it is. Oops. And multiply it, of course, times top and bottom. Just like we just discussed, this square root times this square root is just itself. And so 2x minus 3x cubed times the square root of 1 minus x squared would be your rationalized answer that it would be nice to be able to recognize. That's an x. Okay, you should be able now to do all of the adding and subtracting of rational expressions that are on your homework sheet.